to everyone who are watching. I, Aliano Rispulan, together with Jasmine Rose Manzanero and Cristina Rivera from the second group of BSECE1-3. We will be presenting to you our created device that separates hydrogen gas and oxygen from water.
Hydrolysis or water electrolysis is a technology that aims to solve global problems such as the use of fossil fuels by producing clean, renewable energy. It works by using an electric current to produce hydrogen and oxygen gases from water. Hydrogen is a highly efficient fuel source as it only emits water when burned and produces more energy per unit weight compared to fossil fuels. It is used in various industries, including food, metallurgy, and power plants. The significant purposes of water electrolysis are to produce pure hydrogen and oxygen gases. In the experiment, sodium hydroxide is used as the electrolyte and the whisk as the electrode. Oxygen is produced at the anode while hydrogen is produced at the cathode. Efforts are underway to reduce the cost of hydrogen production and make it more viable alternative to fossil fuels.
Focusing on the body of the device we created, we use materials such as 1 2-liter cylindrical plastic container, 7 small plastic bottles, 1 1.5-liter plastic bottle, 3 barbecue sticks, and 3 rubber bands. For the electrolysis process, we use materials such as 2 liters of distilled water, 100 grams of caustic soda, sodium hydroxide, 2 stainless steel whisk, 4 steel wool, 2 alligator clips, positive and negative, half-meter electrical wires, and 1 12-volt battery. On the other hand, we also use 1 graphite pencil, 1 marker, 1 cutter blade, 1 pair of scissors, 1 12-inch wooden ruler, 1 soldering iron and lead, 1 glue gun and hot glue, 1 cutting plier, 1 roll of masking tape, 1 roll of electrical tape, and 1 stainless steel spoon.
In creating the device design, factors such as the effectiveness and the availability of the materials or substances were considered. The electrodes used are WIS, made from stainless steel because they primarily contain chromium metal, an inert electrode. Then steel wools are added to increase the surface area of the electrode where the redox reaction occurs. The electrolyte used is caustic soda because it is not consumed during electrolysis. Sodium can be reduced in water and the hydroxide is continuously reformed as consumed. Furthermore, sodium hydroxide is very soluble in water, so it can be very concentrated, allowing for a high current. The materials used in the body and the base of the device are very accessible and it can be found at home, such as plastic bottles and plastic containers. Assembling the device. For the section where the electrolysis of water will occur, the two electrodes are inserted and glued at the base of the cylindrical plastic container. They are sticking out of the container because this is the site where the power source is connected. Then, two holes of equal size with the same diameter as the head of the small plastic bottles are made at the lid of the cylindrical plastic container. Then, the small plastic bottles are screwed into the hole from the bottom. The heads of the small plastic bottles inside the cylindrical plastic container are sticking out of the lid. Note that the authorities of plastic bottles have spiral patterns that allow them to screw together if twisted enough. Lastly, close the cover of the cylindrical container, creating two chambers that are supposed to separate and funnel the products of the two electrodes. Two new external plastic bottles of the same size are used for the gas chamber, where the hydrogen gas and oxygen gas are collected. First, the top or head of the plastic bottles was removed, creating a hole with the same diameter as the head of plastic bottles that are screwed inside the cylindrical plastic container. Then, these new external plastic bottles with their heads removed are screwed into place onto the leaders of the small plastic bottles sticking out of the lid of the cylindrical plastic container. Remember that the authorities of plastic bottle have the spiral patterns that allow them to screw together if twisted enough.
Since the electrodes are sticking out of the base of the cylindrical plastic container, a platform that will elevate the cylindrical container is required. The three barbecue sticks are fastened using rubber bands, forming a triangular base. Then the ends of the barbecue sticks are inserted horizontally at the center of three external plastic bottles. These bottles are filled with water to serve as the platform's foundation. To utilize hydrolysis device to prepare the oxygen gas and hydrogen gas from the water, we must prepare the electrolyte first. Dissolve 100 grams of caustic soda in 2 liters of distilled water inside a different container to dissolve it properly by stirring the solution using a steel spoon. Once the solution is ready, pour it inside the tank of the device. Ensure the electrodes are submerged in the solution before closing them down. After assuring the tank is sealed, place the two gas collectors on the top of the funnel for hydrogen and oxygen gas. Prepare a 12 volts battery as the power source. Then connect an alligator clip to the battery using electrical wires. As soon as the power source and the conductors are entirely set up, attach the clips to the electrodes to start the hydrolysis reaction within the solution. Leave the hydrolysis reaction for 3 to 4 minutes before detaching the clips. Stop the electric flow between the electrodes and the power source. Here is the last part of the experiment, where we need to prove a separation between the hydrogen and oxygen gas from the hydrolysis reaction within the electrolytes. After detaching the alligator clips from the electrodes, remove the gas collector for hydrogen gas and then ignite it using a long burning stick for safety purposes. Since the hydrogen gas is combustible, there should be an explosive reaction if the collector contacts the flame. Like the test performed on the hydrogen gas, remove the collector for oxygen gas and place the burning stick inside it. Since the oxygen gas is inflammable, there will be no reaction when contact between oxygen gas and the lighter occurs.
Designing and creating an electrolysis device is considered to use only recycled materials for availability and ease of creating and designing. The researchers use materials such as plastic bottles of varying sizes, containers, and wooden sticks. It is also considered in the significant parts of the device, such as the electrodes using a stainless whisk and steel wool that can readily be available to anyone. Creating and performing the hydrolysis is surely a great experience to our group. As a result of following the procedures, the created device used in performing a water electrolysis is effective. With the success of developing and creating an electrolysis device using recycled materials, the efficiency and effectiveness of the process were observed. Right from the beginning of the process, it is noticed that the inside of the electrolyte solution immediately releases bubbles, inferring an electrochemical reaction. As time progresses, it is significantly observed that each of the respective electrode gas funnels starts to colorize, depending on the element being reacted. In the cathode, the negatively charged electrode produces white fog caused by the release of hydrogen. While on the other hand, in the anode, the positively charged electrode has a brownish or rusty color due to the release of oxygen. At the 3-minute mark, it was significantly noticed that the reaction taking place was sufficient for observation of the experiment. Hence, the researchers disconnected it from the power source. Overall, We concluded that electrolysis is a promising technology for solving global problems, including the combustion of fossil fuels and creating clean, renewable energy sources. And finally, in this part, we want to thank you for watching and listening until the end of this video.